Hey, everybody. Welcome to the so far unnamed podcast. Our current thought is taps and patience due to a little incident from earlier this week. But right now we're unnamed. We will have a name in the future. I am AJ Huff of Design the Everything, and I am here with Harry of Precision Ingenuity.
Hi. So, what's going on this week, AJ?
So I've been working on a couple things. Most of them, actually, just about all of them are leading up to my upcoming Kickstarter for the Carabiners. Right now, today, I was working on a robot to stress test my Carabiners.
A robot. That actually sounds like a ton of fun.
By robot, I mean like a pneumatic cylinder on a frame.
Yeah, I kind of figured it was something like that.
With the theory being it's just going to press the carabiner over and over and over again until it breaks or doesn't break.
Hey, it's the simplest of robots, but we'll count it. So, you're going to connect it to an Arduino and like go a specific amount of cycles? Like, how are you planning on controlling it?
I have not really gotten that far yet. Right now I'm just focusing on the mechanical portions. I'm thinking I may just do a simple timing relay that activates a solenoid every second or every 2 seconds, and then sit a camera in front of it in time-lapse mode. And if I know how frequently it's firing the solenoid, and then I can watch the time-lapse to see if and when the carabiner breaks and just get an idea of the general number of cycles.
Awesome. Do you have any experience with Arduinos or any of that stuff? I honestly don't know.
I have a little bit, but it's like 5 years out of date.
Fair enough. Yeah, it's actually kind of funny you bring up some robot automation. We actually got a fiber laser here recently, and I'm looking at automating it for tag production. So in my area, there is a ton of business involved with making these literal electrical tags. So we have a lot of chicken production in this part of Arkansas. And all of the companies that do millwright work and electrical work for them, they have to have tags. And to the best of my knowledge, they all hate doing them because they have these giant 5x10 lasers for cutting up sheet metal, but they kind of are really bad at doing engraving on stuff. They can do it, but it usually doesn't look the best, and it usually can wear off. In addition to the nesters, the guys that are actually doing the programming for that laser, they'll spend 2 or 3 days just writing tags, and they absolutely hate it. So we got a fiber laser for doing some gun part stuff, and I want to see if there's any way I can automate it where I can load a tag, engrave it, and then push it off the table. So we'll see how that goes.
Is it a unique engraving every time, or is it just like 001, 002, 003?
No, that's what makes it so hard for the nesters is that they'll get an Excel sheet that has 500 unique tags, and they'll have 3 or 4 lines of unique text on every tag. So almost nothing is the same from tag to tag. You might have like one where the top line's the same for the first 5 tags, and then the next line down is different, and then the next line down is different, and so on. And so what would make this system work the best is if I can have a way of importing an Excel sheet, writing the text automatically, importing it from that Excel sheet, writing it onto the tag, and have a system where the laser writes and says, okay, I'm done. It talks to like an Arduino or Raspberry Pi, which then moves the tag over, and then it says, okay, new tag's in place, and then pings the computer, and they kind of talk back and forth until all your tags are done. But right now I'm still in the state phase of seeing if that's something that even anyone around here is interested in. This is just something that I've kind of come up with, like, if I can find enough people that I could market this to, there could be something here, but they might all just want to keep it in-house for all I know. So we'll see.
Mm-hmm. Let's see. It wouldn't be that hard to automate the tag image generation. Right now in Airtable, I use it to print labels for my free sticker of the month club. Mm-hmm. And so a user fills out a form online, and that populates my Airtable document. And then from there, I can just open up what they call the page designer and hit
Mm-hmm.
print, and it'll generate a shipping label for everybody.
That's
And so
cool.
if you can convince the page designer to give you a format that you might be able to use with the laser, you could generate all of your files that way.
Mm-hmm. Yeah. I have a friend who I used to go to school with here locally, and he's a programmer for his day job, and so he's offered to help me out with some of the programming on the back end side. So we've
Okay.
done some testing, and uh, there's some libraries out there for connecting to these lasers on GitHub.
Hmm.
So we're playing around with that to see what we can do to connect to it to that way we can, because it's got two different softwares, EasyCAD 2 and Lightburn,
Yep.
and both of those softwares are great for what they do, but I haven't found a way to automatically generate text without doing some kind of a weird macro where I take something in, use a macro to put that on the screen, and then use the macro to start the laser, which could be done. It could be done, but if I can get away from those softwares, I think it'd be a lot more computer efficient.
Yeah. Can you use G code generated in a program like Fusion?
If it was a gantry style laser, yes, but it
Hmm.
is a Galvo style laser, and those apparently use some unique code to control them. You have to download Galvo specific drivers to run them.
Interesting.
Mm-hmm.
Yeah, because like I've done a couple products or projects that have automatically generated and like cycled parameters in Fusion and spat
Mm-hmm.
out G. Like you did you ever see randomized whiskey cubes?
No, no, I didn't.
So that was back on my first Tormach. Um, I had code that would go through and randomize the design on each side of a whiskey cube, like a stainless steel whiskey cube, so that every side would be unique. And it was just choosing random numbers and like placing a spiral in different spots, and then I would
Interesting.
just rotate through the six different sides.
That's really cool, actually. I mean, you seem to do a lot with the setting up a model to be automated. I mean, I remember when you did the parametric pry bars.
Mm-hmm.
Those were really cool. How you had those set up. So I was
Yeah,
pretty impressed.
I so like when it comes down to like what I'm actually good at, like if you look at all the stuff I do for design the everything, the thing I'm actually the best at is CAD. I started doing
Mm-hmm.
CAD when I was like, I don't know, maybe 12.
Mm-hmm.
Um, I remember convincing my mom to buy my dad some CAD software as like a birthday present. And then I
Okay,
just played with it the whole time.
that's
It's called
awesome.
Turbo CAD. Then I eventually upgraded to uh, I went from that to SketchUp, and then in college I learned CATIA and then Inventor and then Fusion.
Nice. Well, that's quite the CAD journey. I don't have quite the same experience. I didn't really touch CAD until I was in college, so
Mm-hmm.
um, but I definitely had some kids that I went to school with that were like coming in as freshmen and they knew how to do everything. And they like I remember one time when I was very early on, I hadn't even done 3D CAD. I was playing in 2D CAD, and I'm sitting here drawing lines of 2D CAD trying to make like a ISO view of something, and the guy next to me is modeling a jet in 3D, and I'm just like, you can do that. So that was very early on. But it was pretty funny to look over and go, okay, I got a lot of growing to do in this area.
How did you get started in machining?
So my machining background is it's pretty much come from YouTube. So my family, as a background, is into cabinetry. So my grandfather started a business where they made cabinets and they shipped coast to coast. And my dad worked up there for many years, and so um, my background's more on the wood side of things. But the wood never really interested me. It seemed too imprecise for my engineering driven brain. Um, And what really got me interested in like metal type stuff was restoring tractors with my grandfather.
Hmm.
And I used to do that for many years growing up when I was in grade school, all the way up through high school. And never really connected the dots to machining, connected it more to engineering. And then when I went through engineering school, while I was in school, I started watching stuff like Grimsmo and John Saunders. Those were really the main two. This old Tony some and a couple other ones. And I always thought that it was like really cool and something that I would love to play around with at some point in my life. And then I started manufacturing stuff. Like after I graduated, I became a mechanical engineer and went to work at a place that made all kinds of stuff for the chicken industry. And I started getting really interested in starting my own business. And the thing that interested me was when I was designing stuff and sending it down to the machinist to machine, he had no experience with CAD or CAM, and he was
Mhm.
programming it on the machine. And so there were several times when I'd ask for something to be done. He'd be like, "Oh, it can't be done," and I'd be like, well, there's this cool thing called CAD CAM, and like, have you thought about doing this or that? And he's like, I've been doing this for 25 years and no one's ever done that. And it's just like, but would it work? And there was a lot of other machine shops that we would send work to around here, and they all, at least on the outside looking in, didn't seem like they always knew what they were doing. Like we sent some square shafts once to the shop, and it had snap ring grooves that it needed
Mhm.
to have cut in it, and they didn't have the tool for it, so they just took a hacksaw while it was spinning on a manual lathe and just cut the grooves in that way.
Oh gosh.
And it was just like, really? Like, you're going to do that? And so it just, now there is some really good machine shops around here. As I've started off on my own and started like looking around to see what's in the area, I found out that there is some really good ones, but they're really have almost no presence on the internet, and they have hyper focused in the area so much that um, like they won't even talk to you because you're not
Mhm.
one of their customers. So because of that, when I was at that other job, I could never find them because they were pretty much already full and had their own things that they'd specialized in, and wouldn't do anything for us anyways. So
Yep. Okay, so I want to talk a little bit about like our businesses, and like I have a
Mhm.
question for you that I want your feedback on. Something I've been
Okay.
considering. Should I start doing Xometry work? Should I make the test part? Should I start taking parts from the job board? Should I make that part of my business, or should I just focus on like my products? My temptation for going to Xometry, I should say, is like right now, I've been working on this carabiner for I don't know a couple of months, and except for selling some early like beta prototypes, they haven't made me a penny. Like they're just consuming money. And Xometry would be a good way that I could get cash flow, but at the expense of focus and specializing.
So what I would say there is that Xometry, if you're looking for cash flow, unless you have the right type of machine, you're not going to make good money. So, for example, we both have a Tormach 1100 MX. Um, there is so many people that have the same capabilities of that Tormach 1100 MX. It's a great machine for what it is, but when you're on a site like Xometry, you're competing with guys that have Mazax, Haas, Doosan, all that other stuff, and they can make the same part that might take us 30 minutes to an hour in 1 to 5 minutes.
Mm-hmm.
And so the pricing structure kind of reflects that. And you know, let's see here. We've done almost 50 jobs, and we've been on it since November of last year. So not quite a full year. And we've done about $15,000 worth of work through it in total. Now that's $15,000 in revenue. So that doesn't include material tooling or any of those other expenses that come out of that. Now, what Xometry has been great for us is it has allowed us to tool up. So it pays for, like, we take a job and that job pays for the tooling and the material. And by the time we're done with it, we haven't really made much, but we've bought everything that we needed for that job, and that job has paid for that new equipment. And then the other thing it's been really good for is that it allows us to take on work that is new and different. And so I can look at a job and I can go, man, I've never done XYZ style part before. I think I can do it. I have, confidence level. Let me give it a shot. And we haven't failed anything yet, but I'd be lying if I said I haven't been out there till almost midnight some nights trying to
Yep.
get stuff done. We've never shipped late. But it has also forced us to become a better machinist overall. My quality of my work has skyrocketed since the time I started on with Xometry, just because it holds you to a standard and forces you to check everything and make sure you are making the type of parts that you think you're making. And
Yep.
in those respects, it has been priceless, because it's given me more confidence to take on work. And it's also given me a little bit of caution to take on some stuff that I was like, man, I thought I could really dominate on this, but it helps you find the limitations of your machine real quick if you take on more than you can handle.
Yep.
So
Okay. And I mean, to be fair, I need to get better as a machinist. Like, I'm good at CAD. I've never really claimed to be a great machinist.
Yeah. Well, it'll force you to do that, and there's been times where I've made pretty good money on it, but honestly, like in the last month, I've had some local jobs where I have basically made the same amount that I made in Xometry over almost a year in about 2 or 3 weeks, just with local work. So, with a lot less stress and with a lot higher dollars per hour. So, in that respect, that being said, we have started taking on some lathe work, and that seems to be less saturated than the mill side. I think there's a
Okay.
lot more people on the mill side of Xometry than there are on the lathe side of Xometry. So that's my thoughts on it so far. And I've heard other people, I've watched other people that have done Xometry work, and I think up until about 2018, 2019, anytime before that, Xometry was amazing for the money that was being generated for the types of parts that you were being asked to make. But as that gets saturated, it's kind of like the first people on YouTube versus people that get on it like 10, 15 years later. And it's just a lot harder to get to the same level.
Yep.
So
what would you tell me?
So my advice to you would be, if you're looking at it for cash flow, I would not recommend. If you're looking at it as something to pay for tooling and to expand your skills, provided you don't take on work that's more than you can handle, it can be a great opportunity. And there is some side benefit stuff that we haven't taken advantage of yet, but that could happen. So they'll actually train you and educate you into becoming, what is it, like ISO 9000?
Oh, really? Okay.
Yeah. With the stipulation that once you've become trained on it, you accept a certain amount of jobs from them for them to justify them training you for that. So like there's some benefits in there beyond just the financial, some certification stuff that you can get through them. And they will upfront the cost of that training and that certification, provided you are willing to do X amount of work or X amount of jobs. I don't know which it is, but so there are some other benefits in there.
So do you think, like, are there, how do I word this? How much atypical equipment does it take to get you above the rest of the pack? Like, I have a fourth axis. Is that enough to really make enough of a difference, or does everybody have a fourth axis? If I buy that little Pocket NC 5-axis, like their new 5-axis with a high-speed spindle, like, is that enough to find high pain work? Like, where's the line?
That's kind of what I've been looking at, honestly. I've been looking at getting the Pocket, their new CNC they're working on, specifically for Xometry work, just because like once you get over a certain point, I feel like you can ask for more money and get it more often than not. Um, and but for Xometry in particular, I feel like if you had a Datron Neo,
Uh-huh.
you could dominate on Xometry. There is a lot of plate work that comes through Xometry that I just go, man, if I had like a Neo or a Neo like machine, man, you could. I think you could do really well on Xometry with something like that. As for fifth axis work, there's a lot of big fifth axis work. There is some small stuff, but honestly, you with a fourth axis would be able to take on a bigger chunk of work um, than I could just by having that. And it's so hard to say what equipment you need because there's so much random stuff that comes through, and some of the stuff that comes through, you look at and you go, "I pity the machinist that's going to have to try to make this part," because whoever drew this up really hated the machinist.
Yeah.
So, but I know there's other platforms that are kind of following the Xometry model, and I would be more interested in finding one of those that is starting up and is less saturated. Um, because I think if I was going for just straight up cash in that area, um, I would definitely look towards that. For us, Xometry has turned less into a revenue generating thing and more into a man, we don't got anything to do right now. We need something to keep the spindle running. It's not going to make us much, but it's better than nothing. Is there anything simple that we can get to throw on? And I feel like that's probably what more people use it for than anything, than as their sole money generator these days. But I could be wrong.
Well, I know like the guys at Cerven Solutions, and all they do is Xometry job. They
Oh,
have a
really?
SIL X7, and they just do Xometry stuff, and it seems to be working for them. I know they did say for like their first year they did not make much money because they were just buying tooling and fixturing and everything to be able to do it. But now that they have that stuff, they are starting to make money.
Yeah, and part of the problem that we might have more than anything, honestly, is that it kind of goes back to that specializing idea, which we as a business are doing horribly right now because we take on almost anything. And the same thing kind of applied to how we looked at Xometry. If it was anything that we felt like we could remotely take on, we did. So, uh, copper jobs, aluminum jobs, stainless steel jobs, titanium jobs. I mean, haven't really done any plastic yet. Kind of held off on those for now, but and then we would do big parts, small parts, flat parts, parts of odd shapes. And I think if you we've confused the algorithm so much now that it just gives
Mhm.
us random stuff and doesn't really know what we do per se. And I think that's probably hurting us as well. I wish I could just like reset the algorithm and then try to focus into one area and see if the algorithm on the Xometry would like give us more of those styles of parts. That way we could do better. Because I think you also said that those other guys, they get mostly plastic parts on their job board now. Is that correct? Do they?
They, I don't know that specifically. Um,
Okay.
when they were doing it on a Tormach 440, I know that they were mostly taking plastic and copper parts, and I think they still do a lot of copper, and they're kind of specializing in that now, whether intentional or just like the feedback loop between we do copper, algorithm gives us copper, we do copper, algorithm gives us copper.
Mm-hmm. Yeah.
Or maybe I've just seen like two of their parts and they both happen to be copper and it's just like 1% of what they do. I don't know. I can't speak for them.
Yeah. What I'm trying to do with Xometry right now, and I'm seeing if it works. If it works, it'd be awesome. Is I'm trying to go for simple, high volume lathe parts because I know I can make good money on those.
Mm-hmm.
And if I can tune the algorithm to try to spit out more lathe style parts, because we do have that Haas ST15 now, and so my ability to produce parts on that is like 10 times as fast as what I can do on my Tormach. And
Yep.
and so my ROI on that is a lot easier to get higher.
Yep.
So
one of the big things that kind of scares me away from Xometry is I can't share any of it. And
No,
like
no,
realistically, right now, my biggest consistent income source is actually Patreon and YouTube.
yeah, yeah.
And yeah,
I've done some really cool stuff with Xometry, and I really was like, man, if I could post a photo of this right now, I know people would love it. Um, and that is one of the biggest downsides to Xometry is that you can't share any of it, and
yep,
it just kills me inside a little bit whenever I make a really cool part, and it's like all I want to do is share it. All I want to do is be like, look at XYZ that I did. It's so cool, but I can't.
yep. And I mean, like I do some engineering work for a company that makes molds. Are you familiar with Ed Kramer and his Neo?
Yeah, a little bit.
Okay, I design the molds that he makes.
Oh, really?
Yeah, or at least
That's
some of them.
cool.
I'm not the only designer, but um, and like I don't know. A lot of that's covered under NDAs, but also a lot of it gets shared on social media, so whatever. But um, wow, I don't remember where I was going with that. Oh yeah, I can't share that. I think that's the moral of the story. So
Yeah,
like I don't share everything I do.
yeah. Yeah, but you do a really good job with your daily vlogs, of getting people small updates, small consistent updates, and that's something that we haven't really posted anything to Instagram, Facebook, YouTube, anything like that, anything social media wise in several months now. And some of that has been done with the type of work we've done. We can't post some of it, and some of
Mm-hmm.
it has been done with just we've been slowed down on the stuff that we want to post. Like
Yep.
we've done a couple product stuff, and I've had I'm probably 3 or 4 months behind on the deck defenders. Like
Mm.
we did that deck defender Kickstarter campaign,
Yep.
and you helped us out some with that, and it turned out really good. There's definitely a lot we could have done better, but for what it is, it did really good, and we got really positive feedback. We got them all out, but my first anodizer, um, I ran into some issues, and it got delayed almost 2 months because of that. And then I'm on a new anodizer, and um, they kind of have like a 6 week turnaround. And so I sent some parts for testing, to make sure they were
Mm.
good. They came back good. And so I sent my first batch, and I should be getting my first batch back from him this week sometime. And so we really, really, in our entire time that we've been in the business, we've only sold 40 products of our own, and that was on Kickstarter.
Yep.
So we've never had like anything that it's like go to our website and buy, which is one of the main things that I started this business for.
Yep.
So now, what about you? Now I've been kind of keeping up with your carabiner sagas. Is there anything that you haven't shared on any of your YouTube stuff that's going on with that right now?
Um, not that I can think of. I have a like sampling set of carabiners out to a guy for product photography, and
Mm-hmm.
that is like the last big thing, at least I think it is, for my Kickstarter. I have the campaign written, I have it all ready to go. I just need to dump those in. And then, oh, actually, no, there is one more big thing. And like, this is kind of where my brain space has been at for the last couple of days is I need to figure out how I'm going to advertise this. Because
Okay.
I want this carabiner Kickstarter to be at least 2 or 3 times bigger than my biggest previous Kickstarter. And I would
Okay.
really like it to be 10 times bigger.
Okay.
Which,
So what kind of numbers is that? Like how many pre-sales, how many is or dollars? Like how are you gauging that?
so to hit my goal for this year or for the next 12 months is I want to do 4 $20,000 Kickstarters and then have
Mm-hmm.
$20,000 of regular product sales. That's like what I'm working to right now. That's kind of my guiding light.
Okay. And
So
what's your biggest Kickstarter so far?
it was the parametric pry bar, which I believe was about $5,000.
Oh, really? Okay.
Yeah. So I need to 4x basically.
Yeah. I think you can do it. I think you can do it.
I know right now, like if I launch doing everything the same way I always have done, I'm pretty sure I'd hit that $5,000 again.
Mm-hmm.
Um, what I'm doing, what I'm trying to figure out this time is the advertising. And I talked
Mm-hmm.
to Tom of Infinite Craftsman, the creator of the Frog Pod, who just did a Kickstarter for $30,000.
Mm-hmm.
And I just talked to him about like literally I had a 2 hour conversation with him about marketing and advertising. And like he used one of those companies that specifically helps Kickstarters advertise.
Really? Because
He did.
I wondered if those things actually worked.
So he had mixed feelings on them.
Okay.
Um, I don't know. You can go watch that video whenever I finish getting it rendered. But basically, he sold a bunch more units, but didn't make any more money on them because he paid for the advertising. So if I remember right, he like what was it? It was something like he paid about $3,000 in total to get like $6,000 of sales. And I think he, you know, between all like he did a lot of prototyping and research development to get there, and then he has to make them and yada yada yada. So I think he about broke even. On my carabiners, I do have a much higher margin than him because I'm planning on selling these wholesale.
Mm-hmm.
So if I put in $1 and get out $2, if I put in $1 of advertising, get out $2, I'm winning.
Yeah. Yeah.
Um,
I
but he
have
also,
noticed. Go ahead.
sorry, go on.
No, no, you go ahead. I'll come in after.
Okay. He did also say that he was even so he hit that number. He put in, X dollars and he got 2X dollars out in sales. He did also mention that like the ads that company ended up using were terrible. They
Oh,
did not really do any creative design for him. They just like took his Kickstarter video and cropped it.
oh,
Yeah.
and they took that much money just for that? Is it just because they posted it other places? Is that their justification?
So they work on basically like time plus materials is the best way I can explain it. So you pay them for like the actual, Facebook marketing. So if they spend $1,000 on Facebook ads, you pay them $1,000 for that. Obviously pretty simple. And then they take a 15% cut of all the sales that they bring in.
I'm following.
So their actual cut really wasn't that much. I mean, it was a couple $100, but all they really did was set up his Facebook campaigns for him and crop his videos.
Yeah, that's not much. That's something you could easily do without going through that.
The
Now he
value sorry,
Go
the
ahead.
value of using a company like that is they have email lists for targeting advertising. And that's
Yeah,
what I don't have.
yeah. I was gonna say I've seen a couple. There was one I think they were called like Jello or something along those
Yep.
lines.
Yep.
Um,
Jalop.
yeah, that
That's the
one
company
seems
he
to.
used.
Oh, that was.
Yep.
Oh, okay. I was gonna say that company seems to have a lot of really high value Kickstarter pages. So I
Yeah.
I, I thought about using that one, but interesting.
I I'm torn because so option one is I do nothing and just see how it goes. Option two is I do my own ads. I set aside the same amount of money that I would pay them and then run it myself. And by doing that, I get some of the IP developed in terms of like building up those customer lists. And like when you do Facebook ads, Facebook learns the kind of people that click on your ads and
Hmm.
adds them to a list for you. And then you can target those lists in the future. And that's where like
Interesting.
the value is. And the Jella
Gotcha.
people already have that built up and you're paying to get it. But if you do it yourself, then you get that value.
Gotcha. It's
Or
something you got to build over time.
yes, and it's expensive to build up.
Yeah. I would say the only advantage would be for going with the paid advertiser would be when you're first starting out and you don't have that list, getting your product, even if you're breaking even on it, into as many hands as possible so they can spread the word, will really help you for the next one. And then once you've got a decent sized following and you can go off of the paid advertisement and start doing your own stuff, that makes the most sense, at least to me. Because that's one of the biggest problems we're having right now in terms of job shop stuff is just getting our name out there because no one knows we exist. And so it's probably a very similar idea with Kickstarter.
Yeah. Except people go to Kickstarter trying to buy stuff, and you don't really have a arena where people come looking to buy stuff. They just go to Xometry.
Yeah. Yeah. Which we actually have used Xometry sometimes when we're quoting stuff just to upload it and
check the prices.
See how close we are.
Yeah, I bet that's fairly common.
Oh, I'm sure it is. There's been a couple times where I've uploaded stuff and then they've called me and I've been like, no, I wasn't going to buy that. And then they haven't really called me since in a while. So I've uploaded enough stuff without buying that they're like, okay, this guy's just
tire kicker.
It. Yeah. Although I have toyed with the idea of if I bought stuff at a high enough volume, to have Xometry produce it in a time fashion that I couldn't produce it in. Like I've been interested in that. Like if I ever did a Kickstarter that was so big, like let's say I sold 1 million of something and there was like no way I could get that many out in that much time, would it make sense to lean on something like Xometry to augment your production capabilities? Maybe not make everything, but is there stuff you could send to it that would speed that up? And I think as machinists, we don't like the idea of outsourcing. We want to do as much as we can in-house. But there is a real power in finding people that can make things cheaper than you can and at a rate faster than you can. And that's something I've personally struggled with because I love making as much stuff as I can.
Yeah. Well, I've had this thought before is, would I be farther along if I took the, about $30,000 that I have invested in my Tormach and instead just use other people to prototype? Like, how much faster could I have gotten a carabiner out on the market?
Yeah. I don't know. Those are hard questions.
Yep. And I think the answer I settled on was, okay, maybe I could do it, better, cheaper, faster, but it wouldn't be as fun. And what's the point if you're not enjoying it?
Yeah. That's true. I enjoy there was a part that I can share that I made. So spoiler alert, we got our FFL, and so we can officially start making gun parts and gun related items, which is exciting. But I had a walk in right around the time we got our FFL, and he needed an adapter for a muzzle. He had a muzzle that from one gun he wanted to stick on another, and I designed it. It had internal and external threads, and machined it all in one go on the lathe, and it spit out the part, and it came off perfect on the first run. And then I made a couple more because I adjusted a few things. Even though the first one fit, the threads looked a little wonky, and so they worked, but they didn't look right. And so I just ran a couple more, kind of dialing in the feeds and speeds. And then once I was happy with that, we got our Cerakote booth running about that same time. And so I Cerakoted it, and it basically looks like a factory part, and it makes it look like that's how he bought it. And I was so happy and proud of that piece. Like I shared it with so many of my friends that I was just like, look at this. And they're just like, cool story, bro. I'm like, no, you don't understand. I made it. So it's that kind of stuff that it's the whole reason I wanted to do this in the first place, is because I love, coming up with an idea, modeling up, programming it on the computer, running it in the machine, and then sandblasting it, powder coating it, or anodizing it, or Cerakoting it, whatever, and then looking at a finished product and go, this was just a thought in my brain, and I did the whole process in one area and had a finished product when I was done, and it's just the coolest feeling in the world, and that's something that that's where my heart is in the business, and that's the kind of stuff that I just go nuts over.
Yeah, I feel like I had kind of lost some of that joy lately, is like, because I've just been like troubleshooting the
Mm-hmm.
troubleshooting the carabiners. And I don't know how many of those I made before I got one that I was happy with. Um,
And that's part of the process, because if you're anything like me, when you first machined something and you made a box and it might have been out of square, cut on an angle, you didn't clean up all the sides, but you, gosh darn it, I was the one that machined it, and it looks like the most beautiful thing I've ever seen in my entire life. Like, as you progress in a machinist, you kind of go through these phases where it's like, man, I am just struggling, and then you conquer that thing, and then you have a few really good wins, and then you find something else that just starts kicking your butt, and you're just struggling, and then it just kind of goes in a cycle. For you, I would say you're probably going through the cycle just because you've changed up your process and you're doing something you've never done before.
yeah.
Um, I mean, having a laser cut part and then machining that, um, that's a really unique challenge. And we actually did some laser cut parts here recently for a different company, and they said it's a bunch of blanks, and it was a nightmare to machine.
Mm-hmm.
And so we were lucky because all we needed to do was like drill and tap a hole and cut a slot in it. But I mean, every single, and I'm guessing your parts came out better than the ones we did, but I mean, there was 20 thou plus or minus on all the parts.
Ooh,
And
yeah.
so, and they got mad at us for not hitting center on some of the test parts. And I'm just like, your lasers cut parts are all over the place, and you're
It's
expecting me to hold center line? Like, do I have to probe every single one of these when they're my jaws to make sure they're on center? Like, this is ridiculous. I can't run efficiently doing that.
yeah. With the Sen cut Sen parts, they were all like -5 in all of the dimensions. So they were 5 thou under, but with like if you adjusted for that, they were +or -1.
Okay, that's
So
good. That's real good.
yeah, they were undersized but repeatable, precise but
Yeah,
not accurate.
yeah. Well, I would take that over.
Oh yeah, accurate but unprecise.
Yeah. I would take that in a heartbeat. Um, yeah, it's. I actually had a fun part that I just ran today. I had a guy that was a walk in. He wanted a couple bushings for some bearings,
Mm-hmm.
and he wanted them to be a light press fit. And measuring the ID of a bearing with calipers, those things are to tenths of an inch, and to get most of your press fits, they're in tenths of an inch. And I don't have
Yep.
anything that measures that precise, and so I got it within a thou. And the first one I pressed in, I was beating on it with a hammer, and I could not get it. Like, I got it in there, and it was a press fit. And then the second one, I took 2/10 out of it on the diameter, and it just slipped in. Did it, like, they measured basically identical, and it just slipped into the bearing, and it was like,
Yep.
it was like a really nice precision fit. But I was like, man. And then I went back and I took 1/10 out of it, or put 1/10 back into it, and ran it again, and it was just a perfect, like, you couldn't push it in by hand, but you could just lightly tap it with the hammer, and I was just like, man, these are just tenths. And I've never been able to do anything like that on the Tormach. So being able to do
Mm-hmm.
it for the first time on the Haas, I mean, it's magical.
Yep.
But that machine can produce parts better than I can accurately measure consistently.
Mm-hmm.
So
So I've got some new tooling and a new process coming in. The process is in my head. The new tooling is coming in, and I want
okay.
to try out something. Have you ever done any tabbing off of a part with a slitting saw? So like machine the part and then tabbed it off from underneath with a slitting saw?
Oh, I've used a slitting saw. I don't know if I have actually. I know I have one, but I don't know if I've ever. I don't think I've ever used it. I've wanted to, but I don't think I've ever used it. So, what you going to do with it?
So I want to make some very small titanium flexure carabiners,
Mm-hmm.
basically to like kind of halfway between like a keyring and like a quick disconnect. Like a keyring,
Mm-hmm.
you can get your keys on and off easily. And I think I want to take titanium 1 inch diameter rod and stick it straight up, and then
Mm-hmm.
mill a carabiner out of it, and then slice it off like a piece of salami with the slitting saw, and then immediately go and machine the next one, and then slice it and machine it. And
That
these things are only going to be like a 16th, maybe an eighth of an inch thick. And so if you stick out a 1 inch diameter rod 3 inches, you get like quite a few salami slices off.
so. Hmm. I was thinking, could you cut enough to do two salami slices in a row? So, like, if you come in with your end mill, could you go deep enough to be able to do two cuts and get two?
Potentially. I think the majority of that part, I shouldn't say the majority of it. A lot of that part is going to be because a lot of that part is going to be machined with a 1/32 inch end mill,
Mm-hmm.
and I don't want to go too deep with a tool that small.
Yeah, that makes sense. That one's going to be a fun one. I think that one will be really cool for a lot of people. Are you planning on using a traditional end mill, or are you planning on using like a high feed end mill?
I have been using the high feed mills for my current carabiners, but that's a
Mm-hmm.
120 diameter tool, and like they're kind of hard to find smaller than that. I've never seen a 1/32 inch high feed mill.
You should. There was a video, and granted, neither one of us have a spindle that can go over 10,000 RPM,
Yeah,
but um, Grimsmo, he had a video on high feed end mills. Did you ever watch that one?
I probably did, but it forgot.
It was one of the first times I've seen some of that high feed stuff, and it was really cool. But he had, I want to say it was like a 1/32 or smaller. It
Hmm.
was whatever he uses to slot his the bar that holds your knife, the
Okay, the lock bar.
yeah, the lock bar. Um, whatever he was using to put that slot through, he was using a traditional, and he got a high feed, and he was turning it at like 30 to 50,000
Yeah,
RPM, whatever that thing does,
current
and
RPMs.
yeah, yeah, current RPMs, and his machine time actually went down, even though he was taking a much smaller cut.
Yep.
And he at one point he um, gets some chips on his fingers and sticks it in a microscope, and you like zoom in, you can see like chips stuck in like his fingerprint,
Uh huh.
or like the grooves of your finger, like is so tiny. It's like
Yeah, I'll
sawdust.
definitely have to go rewatch that. I am having tool life issues with my high feed mills.
Okay.
My first one lasted about 25 carabiners, and then my second one lasted about 10. And I think the 10th one came loose and like vibrated it to death. But even still, like 25 carabiners for a $40 tool isn't exactly where I want to be.
I know that the smaller your tooling, the more you have to make sure it's on center, because
Mm.
a thou or two of deflection on a tool that's a 32nd in diameter or a 16th in the diameter is, like 5 to 10%
Yeah.
or whatever. And
These
so, like,
these ones they're just under eighth inch. They're 120 thou. And I just got a brand new Mara tool end mill holder, like a set screw holder. So that
mhm.
should have pretty good run out. I didn't actually measure, but theoretically it has good run out.
Yeah. Speaking on measuring that kind of stuff, um, do you have some nice measuring tools to actually measure, like how much run out you actually have on any of your stuff?
Yeah, I have a Mitutoyo tenths test indicator.
Okay, that is awesome. I have nothing of the sort. Uh,
Okay.
I have the Noga knockoff arm that came with the Tormach, and it has whatever knockoff brand of indicator on the end of it on a spring tab arm with a twisty screw to try to set it at the tip. And I was trying to use that to indicate in some tool holders on my lathe, and I was getting like plus or minus 7 or 8 thou off center, and I was like, this is insane.
Yeah.
And so I went and borrowed some indicators from my local machine shop and put it in there, and I'm like, okay, this is less than a thou. I think my indicator,
interesting,
because like when I was rotating my indicator, I was rotating it with it sticking out, and so it was rotating around the part, and when it was going on the underside, that spring had so much flex in it.
Yep.
That like
and gravity.
Like gravity alone was just moving that indicator, and so I was getting inaccurate measurements all over the place.
Everything is rubber.
Everything is rubber. Oh my! I listened to that one too. That was that Within Tolerance that did that?
I know that phrase from Robin Renzetti.
Oh, okay. I was just listening to Within Tolerance podcast here a couple days ago. They were talking about diamond turn machining, and he used that same phrase, everything is rubber. And I was like, it's true. Like the tighter you get on everything, it's just everything moves.
Have you watched the Robin Renzetti videos?
Is that the one with the air bearing machine, or Robert Renzetti? Which one is that?
So Robin Renzetti is kind of a more older gentleman who does super high precision stuff. He was working on a spindle for his grinder, or like a rotary table, whatever you want to call it, where he was getting the run out and like parallelness and flatness down to millionths.
Yeah. He was the one that did the air bearing like granite custom lathe, and was that him?
Maybe. It's not ringing a bell, but maybe.
Because he was talking about going to the millionth, and he used an example where he had 2 cylinders, and the inner cylinder he could cap off to not let air escape, and he'd spin it, and it was riding on air, and it was like to a millionth, and it was just like there's nothing special about these parts other than the precise air gap between the two of them that won't let them separate, but it can spin freely, and they're not touching, and he puts like a electric thing to show that they're not conducting electricity. Like crazy stuff.
I don't know if we're talking about the same person. I haven't watched his stuff recently enough to remember if he did do that. Go Google him or YouTube him. Robin Renzetti, if you can spell it, because I can't. He has like a great series on rebuilding spindles, precision spindle rebuilding and stuff.
Gotcha. I can't say that I've seen this guy.
Oh, you need to watch all of his stuff like immediately.
Yeah, I'm going to.
If you want high precision machining stuff.
Okay. Yeah, I'm going to have to watch this guy.
Yes, you should. So, I have this tendency to get excited about things and then ask everybody questions about them. And you caught a little bit of this madness today. I really want a laser.
Yeah.
If I want all the lasers, and I'm having a hard time deciding if I should, which one I should get. Should I get the little one that's cheap now and use it, and then get the big one if I decide to later? Should I just get the one that does everything I want to do?
For your average machinist, they might not have the same magic in their eyes when they see one, but as someone who's designing their own products or trying to, lasers are magical, and they can do some really cool stuff. And I was playing around with our new laser, and it is so wild. image quality you can get out of it when you're marking stuff. I had a job that came in this week, and it was a sign that they wanted engraved, and I was testing it out on like a 1 inch by 1 inch square, and it just, even at that scale with all the details shrunk down, it still looked phenomenal. And so it's so cool, so cool.
Yeah. The basically the one I was looking at was, it has like a 40 by 63-inch bed, and it was 150 watts. It won't do any sort of metal, won't mark metal, unless you're like burning powder coat off to engrave. But I don't know. I'm torn.
Yeah. Now, packaging wise, how could you use one of those? Because like I've you like do you have a 3D printer? I'm assuming. Do you have a
Yes,
3D
I do.
printer? Did you use it much around your shop?
Not as much as I would like. I have one that, like, my better one is at, well, my day job, which I'm now part time at, and I don't know. I used to use it a lot, and I've kind of fallen off. And then I have another one at home that's kind of crappy. I would use it more if I had a nicer one, I think.
Okay. Well, if it's anything like our 3D printer, we use that for everything around the shop. It's almost always working on something, whether it's a test print to see if we like the fitment and stuff before we machine it out, or if it's tool organization. I've actually used it a lot for work holding in the mill and in the lathe. Um, those laser cut parts. I made a jig that could hold 8 of them at a time in a vise, and because they were 3D printed, they could take up some of
Yep.
that variation, and it came out great, and they held up through everything. So I was very impressed. But with a CO2 laser, I would be interested in to see what I could do on the packaging side of making my own custom packaging for products. And could you buy like cardstock that's been printed and then laser it out to shape? Like,
My The way I would use it for packaging is I would just get a big sheet of cardboard, put it in there, and then, cut out some shapes. And like, really all I need is just a flat piece of cardboard that the carabiner will go onto. It'll either like clip onto it or zip tie on.
mm-hmm.
And then you can just hang that on a rack at a store.
Okay. Are you looking on putting it? So when you say stick it inside it, are you just making a single sheet? Are you putting a barcode? Are you putting any uh, labels or
I would
anything?
put I would put a sticker onto the cardboard.
Okay. Yeah. I mean, we ordered some custom packaging a while ago for our deck defenders when we did the Kickstarter, and it ended up costing $1 or $2 a box, which we were lucky because it was a really small box and it was full color. So that was really cool, but I wasn't as impressed with the quality from that particular company as I thought I would be.
Yeah.
So yeah, if you did your own packaging, you could. I feel like you could you could do some pretty special things as you played around with it over time that could make you stand out instead of going with the same type of packaging everyone else is doing. Um, have you listened to the audiobook or read the book? What is it? Be Different or Think Different or Something Different.
Who's it?
It's
Who
by
by?
Mike Michalowicz.
Oh yeah, it's like Think Differently something. Yes, I've listened to that.
Yeah, I was just listening to that one. I was driving around this last weekend on a long trip, and I was listening to it, and his whole deal was, if you can stand out and be different from everyone else around you, sometimes that's enough to push you over the edge to get to do better. And that's honestly something I've been thinking about for our business, trying to figure out how we can be different to try to attract customers. But in terms of packaging, that laser could allow you to be different in your packaging if you could come up with some unique ideas that and prototype some ideas to stand out.
My other thought process I have a couple thought process for the laser. But in terms of prototyping too, a lot of my products are, in fact, I think everything right now starts as a laser cut part and then is machined down. And it's like, well, if I can, very quickly go through 10 different iterations of a titanium lanyard hook just to get an idea of shape and feel, that would save me a lot of time. And like when you're not hindered by your tools, like you can be more creative.
That is very true. As we have grown in capabilities, our ability to come up with unique things and take it all the way from idea to prototype. It goes back to that whole adapter, for that muzzle adapter thing, like being able to, because I designed it, I 3D printed it, I test fit everything, and then programmed it, machined it, coded it. Like the ability to do all that stuff in rapid succession is amazing for product development.
Man, you're gonna talk me into buying a laser. I found that there is a slightly older model, like 1 year older, is 6,900 instead of 87 plus shipping. 6,900 with free shipping.
Yeah,
it's it'll cut 3/4 inch plywood in one pass. You can make shop furniture.
I know what you need to do. I know what you need to do. You need to say that if you can reach a certain goal, like you said, you want to get $20,000 on your Kickstarter campaign, right?
Yep.
You want to do 4 or 5 of those a year. You should try to force yourself to go a little bit higher than that, and use that laser as the goal that's going to drive you there.
If I hit 26,000, then I get a laser.
Yeah, there you go.
The other option is I spend $1,800 and get a perfectly capable but much smaller laser.
Yeah. But yeah, it's you're so close to getting your current Kickstarter going that I would suggest waiting until at least that one is done.
Yeah.
And using that as a gauge for if you can afford to get the nicer one or go the more economy route.
Yeah, that's the conclusion I came to myself.
Yeah, as much as it hurts to leave that potential sitting out in the ether, waiting for you to finish up that, that's probably the wiser thing to do.
Yep. And focus is something that I'm kind of notoriously bad at in business. Like I have so many things that I want to do, and honestly things that are more exciting to me right now than carabiners. And I don't know. Should I give you one of my ideas? This is my if design the everything doesn't pick up business idea.
Okay.
I want to do end mills that are specifically designed for less rigid machines. Things like Shapeokos and Nomads, Pocket NCs, etc.
Okay.
It'll be
go ahead.
Let me finish my pitch. There'll be single fluid end mills that are like they have a half diameter or maybe 1 diameter of flutes on the end, and then a relief shank of like 3 or 4 diameters. And so that way it's like a super, super rigid tool, almost like a feed mill, because on those machines, you don't use more than, 100 or 10 thou or 20 thou of flutes anyway.
I like the idea. The only thing that I would wonder is how in the world are you going to get something like that produced?
That's super easy. There's all kinds of companies that grind end mills. Like You can get them made in China. You could get them made by like Lakeshore Carbide.
I guess. I guess I personally don't have much experience. My whole experience in life up to this point has been mostly anything that I want I have to design and make myself. So I
Mm-hmm.
am horrible at finding people to actually manufacture something for me. And
Yeah.
so to me that sounds crazy, but if I mean I know there's people that do that kind of stuff all the time. Amazon's full of stuff like that.
Yeah, I say that's how most products nowadays are made. Is somebody goes, I want to make a slightly better sock, and so they go to
Yeah,
China, they find somebody who makes socks, they change the thread and the color or whatever, and they're like, these are my socks now. I make these.
yeah, it's true. I mean, there's tons of people that do it. Um, I have no experience with it, and I'd love to learn, um, because there are definitely products that we've thought up that, um, would be real easy to send to someone else, and I'm sure they could make it for a tenth of the price that we can make it for. But I have a hard time of letting go of things once I start making them.
Yeah. No, I get it. Then you start looking at margins and like,
Well, for me, I've always enjoyed the game of making them and then seeing how much I can get done in like a single cycle and how
yep.
fast can I get it, the optimization. Like I enjoy all that stuff too much to hand it off to someone else and be like, make me a million of these. Like, no, I can do it. So and then I can justify getting the $100,000 new machine or
Yep.
maybe 10 years down the line, my third or fourth Kern, and then I can compete with John Grimsmo.
All right, I've got a question for you, and this is going back like 10 topics.
Okay.
So we were talking about Xometry and how there's a bunch of plate work on there, and if you had a Neo, it would be great for Xometry. What does the Neo do? Like, what kind of plate work? Like, what? How do I word this? Why do you need a Neo? Why can't you just have like a Tormach with some mod vices? Like, what is that missing that the Neo has that the Tormach doesn't?
For me, the plate work, and I guess if you had a vacuum plate on your Tormach, you'd be able to better compete. Because that's one thing that I've looked at doing was getting the Pearson work holding SmartVac 2 or
Mm-hmm.
SmartVac 3, I think he's on now, for the Tormach. But the reason I like the Neo over just doing that is a couple reasons. With my Tormach in particular, I've noticed that when I move the x-axis from one extreme to the other extreme, it's really hard for me to keep accurate parts in the z dimension. I get almost 3 to 4 thou of deflection from one extreme to the other with like a parabolic pattern as the weight of the table shifts on the
Yeah.
Gibbs. And I've tried tightening it up. I've tried playing around with it. I've got it down to about a thou or two at best. But it's been a challenge trying to get accurate on long parts like that, and that's just built-in error. That doesn't include any error from clamping or anything else that I would do. And so for plate work, anything that's less than a quarter inch and it's bigger than 4 or 5 inches, I just don't touch on Xometry anymore because I've done it, but I've hit my head against the wall and like had to like go in with a fly cutter and cut and then just check everything, reclamp it, like find the high spot and try to clip it down and like made like 10 different plate parts trying to get one that's good. And the other reason I like the Neo is because it's got that smart vac, so you don't have to perfectly gasket around them.
Yep.
And a lot of the stuff on Xometry, at least on the plate side that I've seen, you don't really have more than 10 parts most of the time. And so for the smart vac, with that vacuum card, you could just set a part down, touch it, and then go. And if you're drilling and tapping holes and whatnot, I feel like it wouldn't be a problem on the Neo versus having to make a custom gasket fixture every time if you're using a Pearson SmartVac.
Mm-hmm.
Um, Now, I have used the super glue tape method. That's honestly how I fixed most of the problems that I used that I've run into. But then it's like I usually have to wait about 15 minutes in between glue ups to actually
Yep.
run it to make sure everything's cured. And it's just, you're wasting so much time doing that. If, like, for example, if I have a plate that's, say 4 by 8 inches and a 1/4 inch thick, Xometry might pay me $120 or $100 for that part, and I spend, let's say, $20 or $30 in material for that part, and then I end up spending 3 hours between um, sticking a plate in there, decking it down, doing my first glue and tape up, putting it down, trying to make sure it's perfectly centered, and then waiting for the glue to dry, machining everything, trying to check it while it's in place as best as I can, then flipping it over, doing all of that a second time, and that's assuming it's just a two side part. And then I'm an hour or two into it, not including programming. And then you got inspection that you got to do, and on some of those plate parts, my goodness, there's some that have like 40 tapped holes in. With Xometry, you have to check every single hole on every single part, and you have to do an inspection sheet. And so when you get up there and tapped holes, it might not be that big of a deal to program, but boy, is it a pain to try to measure all those things out. So you got to do all that. And by the time you're done, man, I'm making like $20, $30 an hour. And there's just more efficient ways that it can be done that like make me not want to have to mess with that. Like I don't want to fight it for like, unless I'm doing absolutely nothing and I can usually find something to keep me busy. I've just gotten to the point where it's like I don't want to mess with plate work on the Tormach. Like there's
Yep.
better machines that can do it, and it makes a lot more sense to do them on those machines versus the Tormach. It's a great machine. You can make wonderful parts on it. But I mean, I think back to when Grimsmo moved from his Tormach to his Morisiki. He's like, I can make just as good of parts on the Tormach as I can make on the Morisiki. The only difference is I just have to hit cycle start on the Morisiki, whereas the Tormach, I might have to run it, check it, run it, check it, run it, check it, and then I can get there.
So you know about CA Glue Kicker, right? Super Glue Kicker?
Like the stuff that cures it?
Yeah.
Yeah, I've tried that.
Okay.
And it works, except for the problem is that I run into is with that big plate stuff. If I'm trying to get it lined up on my fixture table, when I do the spray stuff, usually the plates are so big that I can't get it into the middle unless I do the spray on one side and the super glue on the other, and then I have to be straight. And the problem with the Tormach is they don't have like a coordinate offset like some of the nicer machines, like some of
Like
the higher
rotation?
end machines. Yeah,
No, they have that. You can do that.
they do.
Yep.
How do you do that?
The only are you ready for this? The only way you can do it, well, okay, I'm sure you can do it by G code. But the easiest way to do it is to post a probing routine from Fusion.
Okay, so you can actually because that was my biggest problem, and what took so long was I gave up on that because I could never get it perfectly straight, and so what I would have to do the glue up and have to push it against something and make sure it was good straight. And even if I did the spray around the edges, it wouldn't cure the center.
Yeah.
Ask me how I figured that out. I've thrown a few plates. And so I just gave up on trying to speed up that process, and I would just put the glue down and I'd grab a bunch of scrap material and pile it up on the machine and let it sit for 15 minutes at minimum to make sure it was all cured so I wouldn't throw any plates. And so, I mean, just for me, and like I said, I'm sure there's better ways to do stuff than the way I've tried it. But I just felt like for the money versus the time investment, it just wasn't penciling out.
Yep. So I literally, like, right before I got on this call with you, I set up a part with the super glue method. Except instead of having the tape, I made I don't know if fixture plate is the right word or arbor, but I don't know. I have a grid plate that has like little channels cut in it that gives the super glue extra teeth, and I
Mm-hmm.
just do metal to metal on there.
How do you clean it up when you're done? Do you just use like an acetone?
Acetone, yeah. And except, so I I put kicker on the part and the super glue on the fixture, and I stuck it on there the first time. And for some reason, I was like, oh, I whacked down with hammer to make sure that it is set. And as soon as I hit it with the hammer, it popped off. It was like, oh, yeah, super glue doesn't like impact. I don't know why I did that. That was dumb. It was already cured. And so then I had to go clean it off again and, very carefully line it up the second time. But yeah, I would have
So
had that part done if I hadn't whacked that with a hammer for no
yeah.
reason.
Now the super glue tape method is magical. I think it is an amazing way to hold parts, and I've used it to great success. It's just the speed element of it. What I never was able to, at least until now, if I can actually do the coordinate offset, where I could just slap it down, figure out where my zero is, and then machine it in that orientation. Um, that would make it a lot easier than what I was doing.
You have the Tormach probe on your Tormach, right?
Yes. Mm-hmm.
Do you have any accuracy issues with that?
I have, but I've been able to fix all of the accuracy issues, and I've actually, oh my goodness, I have. So I bent the probe at one point,
Okay.
um, into like a U shape almost, um,
I'm not going
and
to ask.
and I busted the little metal ball on the end off of it, and then that was the only way I had for indicating things in. And so I bent it back straight and super glued the ball back on. And I actually was able to use the grub screws on the top
Uh-huh.
and get it re-zeroed in to where it actually was measuring accurate parts with that really poorly held together, looks awful probe. And I used that for a couple weeks until a new probe tip came in.
Mm-hmm.
Um, so, needless to say, I have gotten really, really good at getting the probe dialed in because I have done it like 20 times because I've had errors with the probe not reading right. And so I set it up and I'm like, okay, I'm good. And then I start getting wonky parts for XYZ reason. And I check my probe. Oh, there's something wrong. Oh, I set it up wrong. Let me try this. Oh, I think I'm on. I'm more accurate than I was last time. Anyways, I've gone through that cycle so many times that I finally got to the point where I can actually get it dead set zero and know the size of the ball at the end and know that it's in the right spot. And also, one thing on those Tormachs, or on any of them, not just the Tormach, but I have a scratch mark on the one of the dog bones, and I know that that's where my probe's got to go in on that because if I do it 180 degrees, it'll be off a couple of tenths on the underside.
Huh. I wonder if that's some of my problem.
And
I
so yeah.
I did a part yesterday where I had like my part was like an inch and not three quarters, like an inch and 3/8 tall, and my tallest end mill was an inch. And so I had to do a flip so that I could machine it from both sides so I could do the full profile. And like, it's fine. This is for my robot. Like, it's going to be sandblasted to powder coated. Like, I knew there was going to be some mismatch there, but it was a lot more mismatch than I expected. It was probably 10 thou, and it's like, oh, I wonder if this is my probe. It's probably my probe.
So in my experience, there's a couple gotchas with the probe. One is it's not perfectly set up in the beginning. So if your grub screws and your whole like getting it actually centered, it can the way it's on there is you got the part that goes up into your spindle and then your probe, and it's held together on like a
It's kind of like a four jaw chuck
yes,
with
exactly,
set screws. Yeah.
exactly. And so if that's not perfectly set up centered, you're in trouble from the get go. Second thing that I've had happen quite often is that the probe tip is just a little bit loose in the actual screws, and so you have to. I always crank it down, and I think I got some Loctite on it now to make sure it's fully seated, so that probe tip doesn't have any wiggle between it and the probe.
Okay.
And then the last thing is making sure that you're always inserting the probe the exact same orientation on the exact same dog bone each time. And so I took a file and shaved off one of the dog bones a little bit just on the outer side just to scratch it up some. That way I know that that's the dog. I used to Sharpie it, but that kept wearing off with the stuff. So I just scratched it up just a little bit on the outside. That way I know that's the and I've got my probe set to where the name matches up with that scratch marks because I've reset the probe so many times. That way, I always know that that's how my probe goes in, and I've probed um, on my jaws or on my vise in my machine, and then checked it 2 or 3 days later, and it's be within a couple of tenths of what I measured the first time. And before I did all of those different things, like historically, I would be within a thou or two, and so I went from a thou or two of accuracy over a couple of days down to like tenths, just by fixing a couple of different things here and there.
Okay. I'll just go through the dial-in process with mine again. I'm now that I'm sitting here thinking about it, it's like, oh, I haven't even checked that since I moved the machine. Maybe I should check that.
Mm-hmm.
And I also don't know if I've been consistent about which way I put it in.
Yeah. Yes. There's some things you can check, and you've used I didn't know they had this until I was digging into it because I was doing it all manually. But on the probe setup page, they actually have a deal for making sure you're on center, which makes it a lot easier.
I did not understand what that tool did the first time that I tried to dial one in, and then I think I watched a tutorial on YouTube, and I was like, oh, that's way easier than trying to do it with an indicator or whatever.
I would what I was doing before I had that was I would probe against my vise, and I would label my screws 1, 2, and 3. I was doing the exact same thing that thing did, but I had like a piece of paper or something, and I would
Yeah.
just know that my 1 was my 0 point, and then I'd measure 2 and 3 in relation to 1, and if it was high, I'd go in or out, and if it was low, I'd do the inverse. And eventually, I found that tool, and I was like, oh, this is much easier, much quicker.
Do you have like a gauge ring or anything that you use to check the functional diameter or whatever they call it?
No, I do not. What I actually did to check that was, and I don't know if I know this is not the proper way to do it, but it works. I use a gauge block, and I know a gauge block is or not a gauge block, a 1, 2, 3 block. And so I will probe on the outside and then probe on the outside of the other. And if my measurement's large, then I know that my probe ball is too big. If my measurement's small, my probe ball is too small. And so I'll check it in like the Y until I get it within like a tenth or two. And then I'll go over and check the X in relation to that. And if those two check out and are measuring about the same amount of error, I know my ball is pretty much dead on. Because I don't have the ring gauge.
I used to do it with a 1/2 inch end mill holder, like a set screw holder. So I was like, it's got to be a pretty precise bore. And I think it actually worked pretty well. That was back in my old Tormach where I had the Drutronics probe. And now I actually did buy a used gauge ring off of eBay. And I have 3 magnets stuck to the bottom of it. And so I can just stick it down to a metal surface and have it measure itself.
Yeah, I tried using a bunch of different tools that I had that were circular, but none of them were accurate enough that that was one of those other problem areas that I kept running into where I'd set everything up, it'd all be perfect, and then I'd realize that the ball was the wrong diameter. But the the thing that was the most accurate for me was using the 1-2-3 block. That got it pretty much spot on because it was something that was ground in a known dimension that I could reference.
I can do that as a test when I do mine. Yeah. Though, to be fair, with my old mill, and doing it off of the tool holder, that mill had 13 thou of backlash.
Oh no.
So yeah, the probe was the least of my worries.
Yeah, yeah, that's a lot of backlash.
Yeah,
But I mean, if you have your backlash compensation set properly, in theory, it shouldn't be a problem, but or not as big of a problem. But
yeah, it's still a bit of a problem. But like, I gave it to the guy who bought it with a new set of ball screws, so like it just needed to be. It actually was only in the Y. The X-axis was fine. The Y-axis. So I gave him a new Y-axis ball screw with the mill, and he replaced it. And that mill's making parts. So
hey, that's what matters. Yep. I mean, with the right parts, they're phenomenal machines for what they are. I've made some really awesome parts that I'm extremely proud of on that thing. So,
have you run 1/2-inch tools in yours? I've only ever gone as big as 3/8.
I've run 3-inch tools.
Okay. Have you run like a solid carbide 1/2-inch?
A face mill. The largest solid carbide tool I've run is I ran a 1/2-inch long reach end mill. It was like almost 4 inches of reach.
Gosh,
on a 1/2-inch tool. Talk about tool deflection. That one was a fun one. But it worked. I made good parts. So I had a it was a U bracket where the legs of the U were like 3 inches tall. And it was a custom size, and I couldn't find any U channel stuff that worked, so I had to make it out of a solid block.
Okay.
And so yeah, I had to get like a 3.5 to 4 inch long reach 1/2-inch end mill to machine that out with. So I'd go down with the my normal end mills as low as I could.
Yeah.
And then I'd finish up with the long reach. And that came out really good.
I've always kind of like, it was probably from John Saunders. They at one point said like Tormachs do really well with a 3/8 inch. And it's like, okay, I just 3/8 inches is my max. And the only 1/2-inch tool I've tried is I have a very short, stubby 1/2-inch ball that I use for inside fillets on my trays.
Yeah, I would not recommend 1/2-inch for anything other than like aluminum and plastics.
Okay,
that's all I've ever used it on, and like I've used 3/8 on some stainless stuff, and it is borderline. Like I try to use 1/4 inch on stainless as my max most of the time.
Okay.
On steel, 3/8 is still pretty good. But there again, 1/4 inch tooling is I have no issues with. Like pretty much any material that I can get away with, like any material with a 1/4 inch tool, the Tormach can typically handle. 3/8, your mild steels are okay. Your stainless steels I've done, but it's not ideal most of the time. With the exception of I have a 2-inch face mill that I've used on stainless. And running that, because it's such low RPM, at least for the one I was using, I actually got an amazing finish with it, and I was very happy with that. But like when I ran I went through, I think it was 8 3/8 end mills. Try saying that really fast. And on one job, and they just kept chipping and chattering and exploding on me because there was just so much vibration. And like I would either taking such a light cut that I was rubbing, or I was taking enough cut to actually form a chip, but it was it was chattering because it was not rigid enough. And so when I jumped down to 1/4 inch, all my problems went away.
Yeah, I use 3/8 inch on aluminum all the time, but
Oh
it's
yeah,
aluminum.
yeah.
I like the Lakeshore variable flute, like polished gullet, 3/8 inch aluminum end mill.
Mm-hmm.
That's one of my favorites at this point.
Yeah. I've actually, I like my 3/8 in my aluminum, but I found that I can push my 1/4 inch to remove almost the exact same amount of material as my 3/8 inch before, because my 3/8 inch I start running out of horsepower. So I have a horsepower limitation with the 3/8, and I have a tool limitation with the 1/4 inch. But I can reach, but they both stop at about the same material removal rate. So I'm at about the limit on the 1/4 inch for how much the tool can take, but I'm at the machine limitation on the 3/8 side. And I'm sure that you could probably play with those numbers. I mean, I think I'm around 3.5 cubic inches to 4 cubic inches on aluminum, but I think Saunders got up to almost 6 cubic inches with like the shear hog. But I have not been able to get that high yet.
I have been closer to 6 with the Lakeshore Carbide 3/8 inch aluminum rougher. They call it like the Taz. You can get pretty good material removal rates with that. The problem I ran into is I don't have flood coolant hooked up yet, and like eventually on my machine I just chip weld.
Yeah.
But I can ramp into stock at like a 15-degree angle with that thing.
Really?
It's awesome. Yeah, it's great.
I've been using the Kennametal Core 5.
Okay.
For a lot of it, and I love that thing. That thing's a beast, but it's probably the extra 2 flutes in there. It just requires a lot more power, and so I start running out of horsepower around the 3.5 cubic inch mark with that tool. And I know when you decrease the amount of flutes you have, you need less power, which is why the shear hog can take so much out, because it's just one flute.
Yep.
So.
Well, we should probably get wrapped up here. Just quickly, do we want to talk about like what your plans are for the next week? Anything quick you can address here? And then I'll go.
I think we're going to try to go to our first gun show.
Ooh. As a vendor?
So, yeah. So if we can get our card cases in, we're working on some challenge coins and a few other products that we've been working on in the back end, along with some. I have a M&P Shield Gen 1 40 cal. I'm going to try to do some machine work on this week in Cerakote. And then we got a couple other handguns that we've done some machine work to and some Cerakote work to, and we can set up a little booth and try to get our name out. I'm trying to use the gun stuff in this area to find people that need machine work done besides the gun stuff. It's almost like a form of advertising.
Yeah.
Because like there's when you're in the northwest corner of Arkansas, there's a lot of gun guys in this area, and if I can find some gun guys that are in the purchasing departments of some bigger companies, and it's like, oh hey, you really like your gun, we also have this that we can do. That's kind of the different way of advertising I'm trying to do. In fact, I was just talking to a local guy, and he said that the guy that used to do all this machine work just got hit up for some production stuff or some job shop stuff, and is basically swamped with that and can't do any gun stuff right now. And so that's why he found me. So
cool.
It's like that's what I want to do.
So let's see. Coming up on the docket for me, I need to finish my carabiner tester robot. And really the big motivation behind this robot, but just besides the curiosity of knowing how long my carabiners are going to last, is I want to get one really nice GIF for my Kickstarter campaign. That's the number one reason I'm building this robot. I'm trying to make it really nice and pretty and like visually striking for the GIF. And with that, I want to do a couple other videos or GIFs that I can use for advertising.
Yep.
I'm trying to come up with ideas, but I want at least 4 ads that I can push out during the campaign. I figured I can do the testing robot. I thought of another one where I could float away a carabiner on balloons to show that it's lightweight.
Could you repurpose your air cylinder to also do a pull test? Figure out how much they can pull apart. It takes to pull them apart.
I suppose I would need to put like some sort of scale in there, and my air cylinder is this big, but
yeah,
yeah. Though, but the pull strength on these is not outrageous. Like, it's good enough for your keys. I'm literally calling it the not for climbing carabiner, because I don't want people to expect it that like it's a mountaineering device. Like, it's for your keys. It'll hold your keys. Don't expect to be able to hang from it.
Yes, but it would still be kind of funny to be like, show a pull test and then like have the weight be like 30 pounds or something.
Yeah.
And it's like not for climbing, tested, confirmed or something.
Yeah, one of the things I've learned over the last couple of weeks is a new editing software called DaVinci Resolve. And it has the ability to do a lot more like motion graphics and like funky video composition kind of stuff. And I'm going to try to find a way to work that in some of my ads. Like, I figured one thing I could do is I could just have like my hand on a green screen, like opening and closing the carabiner. And then I could like change the green screen out to be like, look, it's in Paris. Now it's, climbing Mount Everest. Now it's in space. Now it's on an Aztec pyramid. And just, I don't know. I thought that might be cool. Kind of inspired by the what's it called? The Casey Neistat has a short video that he did for Nike. And he has this really cool shot of him like running across, and then they edit him out into being in a bunch of, this is terrible description.
Yeah. I've seen other videos that are like that. Like I saw one guy who did like a backflip, and every time he landed, he was in a different location. Type deal.
Same idea. Like, he took a trip around the world, and he recorded himself running in all of the different countries, and then spliced those together so it looked like he was running across the screen in background. I could do that with a carabiner. Was the long story short.
Yep.
Anyway, do you want to bring us out?
Yeah. For those of you who have stuck with us through our first podcast, we thank you for hanging on. It was a long one, but once we get talking, it's kind of hard to stop because we both enjoy what we do. And as for me, Harrison and AJ signing out. We hope you'll come back and follow us as on our journeys.
Bye.
Yeah, see you.